my name is Shumpei Kawasaki, and then I'm the head. I'm a part of the directors of RISC-V Japan General Incorporated Association, a nonprofit to promote the RISC-V technologies in Japan. And then well, I'm going to just actually quickly run through this, like how we started it, and then what we think of RISC-V, and then what we think of RISC-V in Japan. Where are we? Where we are in the RISC-V Japan. I am. Let's see. Since that PowerPoint is acting up with this, so I'm going to reduce this, and then hopefully, if there is some way to get rid of this. Okay, so I'm just going to go through as is. So so we're going to talk about why we are advocating this RISC-V. So I have worked on the 32-bit MCUs, and then security software, and then in 2013 we started the wireless IoT. And then all of this actually got accumulated into this notion that we are looking at abstraction layers of computer, where obviously instruction set architecture is very central to this whole notion of computer, and because open source software and then open source hardware, both of them are actually RISC-V. And then as previous presentation stated, that the open source software is most of RISC-V, but that the instruction set architecture connects like that the software and then hardware. So RISC-V Kyokai, or RISC-V Alliance Japan, was established as a Japanese nonprofit entity in April 2021, after we have been active since 2015-14. And the purpose of this organization is proliferation of like RISC-V, and the proliferation of enabling technologies of RISC-V, including PDK, EDAs, and then all these kind of things. And then, of course, that includes like the cross tools and operating systems and all these things. So we was strongly attracted by RISC-V because at some point it became clear that there are like a very unique properties that makes RISC-V very special. One was like the property of RISC-V as a modular 32, 64-bit, 128-bit instruction set. And then this covers the entire computer real-world applications. And then property number two is, as the ISA designer at one point, we knew that the density of instruction very much was very important. But the density of instruction, how are we going to achieve that the density of instruction makes a lot of like that problem for that software. So the way that the RISC-V achieved that efficiency by having like 16-bit instructions that actually covers maybe 90% of that instruction appearance actually helped. So this is essentially M0 versus like RISC-V, 64-bit RISC-V. But it comes out to be about the same. It shows 15%, but at that time that compiler was not mature. And then amazing thing was like rocket SoC hardware generator. So how this whole concept of hardware generator was something that we were very surprised to just see from like that work of like UC Berkeley. And we actually did build a chip out of it, and it came out. I mean, like University of Electrocommunication, like that we sent student into, and they were able to just actually put together using that VDEC. And property 4 is chip and software implementation to validate architecture element. So every one of those like a features, architectural features, were actually validated by software and hardware. We, of course, like most of people can't do it because it takes a huge amount of effort, and but this is actually being done by RISC-V. And property 5 is like PC cloud high-end resident software environment is being developed for RISC-V, which is like all those Linux effort, all those like GCC effort, all those cross-compiler efforts are actually being done. And then also the library and then application develop like validations, like Fedora and all these other stuff is going on. And here's obviously RISC-V is becoming Debian official architecture now, but the intent to just actually go to like the Debian official architecture was very clear from the beginning. Then property 7 is like Chisel hardware description language has, like that is a basis of like the integrated hardware generator, which I thought was very interesting. And then they actually get the backing from the government. RISC-V got the government backing from that in the US, DOD, from DARPA. And in Japan, like the Linux Opti, that the NATO is backing this effort. And then in the property number 1, and then it's RISC-V turned out to be core of Open Silicon program, which is even as much exciting as RISC-V is. That like Google and Skywater and eFabless, those people are actually using RISC-V as a vehicle of design. And also end-to-end cloud strategy. RISC-V is based cloud AI accelerators, RISC-V desktop PCs, RISC-V laptop being developed for cloud development. So then I would like to move on to just actually mention some things about Open Silicon. So Open Silicon hardware movement is something that RTL design, PDK, and then EDA tools, all of them, they are attempting to just actually make it into an open source. And DARPA's Electronic Resurgence Initiative is concurrent with the RISC-V. And then around the same time that the KiCad, like open source board design tool, came out, open source FPGA tool, Yosis, and then other, like that routing tool came out. And then Open Road program started this digital design EDA tool chain. And then finally that the Google eFabless is starting to just have this very inexpensive 130 nanometer chip ignite program. That's like $10,000 for 10 millimeter of user design area. And finally, that the open source development kit SKY 130 is totally open sourced like PDK. Then finally, like we're going to discuss this RISC-V in Japan. So biggest news of like the RISC-V was Renesas introduced that the RISC-V ASSP, and Renesas on this RISC-V ASSPs and Renesas, like a Sci-Fi RISC-V ASSPs are ongoing. Then small startup called Architect developed AI on IC on RISC-V. And then NSI Tech's AI accelerator, ML041, and then NSI Tech's DR1000C RISC-V vector processor has been developed. And the ubiquitous AI Corporation's RISC-V network framework is being developed. So that more or less sums up that discussion. And I'd like to just actually alert everybody that we're going to have that the RISC-V Day Tokyo 2022 on April 21st and 23rd, 2022. So that's pretty much it. And we believe RISC-V is changing semiconductor industry in terms of players and then in very fundamental ways. RISC-V offers tangible set of assets created tied of like hardware open source. And then open source tied did not stop at digital IPs, but also included EDA tools and then PDKs. So RISC-V is also laying the groundwork for the cloud computing in terms of software. So that concludes my presentation. I think that since I'm already out of time, so I'm going to just actually have to ask Professor Tran to just actually conclude that today's presentation. Dr. Tran is Dr. Tran are you there?
Okay, I'm here. Thank you very much,
okay.
Mr. Shumpei.
Yes.
Yeah.
Okay, please just actually give a closing remark for today.
Thank you. Yeah. Okay, so thank you very much for providing many information about RISC-V Alliance Japan. And we do hope that maybe in near future, we can have more collaboration between RISC-V Alliance Japan and the IC design community in Vietnam. So to organize this event, the RISC-V Days Vietnam 2022, co-organized by RISC-V Alliance Japan and the Information Technology Institute from Vietnam National University Hanoi, with many contributions from Indian Institute of Technology, Madras, Pavatak Technologies Foundation, and University of Electro Communication, Tokyo, Japan. So I would like to appreciate the collaboration of Mr. Shumpei Kawasaki from RISC-V Alliance Japan for hosting this event. So in fact, at the beginning, we would like to organize a face-to-face meeting in Hanoi. However, the COVID-19 pandemic in Vietnam has become worse situation. So we decided to change this event into virtual mode as we attend today. So we do hope that we've been able to meet all of you soon in the next event. I would like to thank all the speakers who accept our invitation to share their work at the event, their experience Many thanks to Professor Hoàng Văn Phúc, teams from Lokidon Technical University, the CISLab from Vinil University, Vinil Information Technology Institute, S8 Consulting Vietnam, Professor Lê Đức Hùng from University of Science, Vietnam National University, Ho Chi Minh City, Professor Phạm Công Kha teams at UEC, Mr. Nguyễn Thanh Yên from Co-Asia, and also from Vietnamese IC community, Mr. Vijinathan Kamakoti from IIT Madras, and Mr. Kimiharu Eto from Renesas Electronics Japan, and Professor Chester Robeiro from IIT Madras. I also would like to thank all the audience for joining this event with us, even in the weekend, on the occasion of New Year 2022 and the new lunar year lion coming. I wish all of you healthy, happiness, and great New Year 2022. Thank you very much.